I'm supposed to actually fold.
I know.
I thought I had this. Okay, fine. Well, okay. No. Oh, I thought this was a clicker. Do you have a clicker, by the way, or should I not? Okay, that's fine. So, what I wanted to talk about today is kind of some of my more recent views on, like, basically what specific underlying reasons there are for why blockchain-based applications kind of actually can outperform, like, basically the centralized things that they're competing against. Because I think we've seen a lot of hype that all kind of go through a bit, and then we've also seen a lot of desperation, which is really just the hype of the bears. And so, like, basically what I wanted to do is try to kind of sort through both of those things and come up with much more specific and concrete and deeper reasons why, for certain kinds of applications, actually sticking part or all of it on a blockchain makes a lot of sense. So, first of all, what's the point of a blockchain, kind of as spoken by enthusiasts, right? So, people talk about decentralization. Yay! Who here does not like decentralization? Who here does not like decentralization? Who here thinks that the UK government is literally controlled by lizards? Okay, so I see higher confidence for the second claim than the first, which is good. Also censorship resistance, right? So Ethereum has kind of always been originally advertised as a platform that allows decentralized applications to run, quote, without fraud, censorship, or third-party interference, and this is one of the major things that people got excited about, right? Even with Bitcoin, uncensorable peer-to-peer money, as Satoshi's quote goes, governments can cut off the heads of things like Napster, but BitTorrent is another story, and so on and so forth. Openness, so we like openness. Inclusivity, you might hear it in the term financial inclusion, banking the unbanked, unbanking the banked. Also fairness, and by fairness we both mean kind of in a very broad philosophical sense, so trying to kind of make the economy fair, but also in kind of very narrow senses, like for example, we talk one category of blockchain applications does provably fair gambling, which is like a very small sector of the economy, but it's still legitimately interesting because it really does allow you to kind of design gambling services in such a way that whoever runs it literally can't cheat, which is something that you really can't do to the same extent before, right? So these are kind of some of the things that people tend to talk about. And of course people talk about things like ledgers and immutability as well, but ultimately, if you ask them why ledgers, why immutability, these are kind of some of the goals that they go after. So, what are some of the challenges in each of these ideas, right? So, decentralization, well, there's definitely people who love decentralization, but the kind of ideological constituency for decentralization as an end in itself is realistically fairly small, right? So there's a lot of attempts at doing things like decentralized Twitters, decentralized social networks, and even going kind of outside of the tech sector to things like seasteading and so forth. And the size of people that are willing to like basically sacrifice the comforts of network effects for kind of just pure abstract ideals is probably not small enough to take the blockchain space to the next level. So you have to ask, what concrete things do we hope to get out of decentralization? What specific property do you want your application to achieve with decentralization that would be significantly harder for it to achieve without decentralization? And also, how much decentralization? Aren't consortium chains with just 5 banks talking to each other decentralized enough? Censorship resistance. So, if you're a political dissident, yay. If you're someone in Venezuela looking to move your money out, yay. If you're a gambler, yay. If you're a weed enthusiast, yay. And there is a kind of long and decreasing list of things for which, if you are one of those constituencies, you can kind of relate to the goal, but especially as you move to kind of broader sets of users, then the clientele for kind of really wanting strong censorship resistance, and especially being willing to kind of make the sacrifices in things like efficiency and usability that at least present-day blockchains basically require you to make is fairly limited. Openness. So sure, openness is great, but if you're a developer or a user, you're kind of skeptical of the technology. This is another one of those kind of nice-sounding, faraway, sort of fluffy words, but what kind of concrete things do you gain by being open? Inclusivity. So developed countries, hey, in a lot of places people just say traditional payments work fine. What's the problem? You got Venmo. Developing countries, how do I exactly get these Bitcoins again? Oh, right, you have to walk like 1,500 kilometers to get to a lemonade stand, and there's an exchange. And also like fairness. So basically, like a lot of people I think would ask, like, when is the last time a centralized app defrauded me, compared to when is the last time I lost money from my private key getting stolen or me losing my private key? So where do I actually disagree with the naysayers, right? So first of all, I think don't discount censorship resistance. So applications that use censorship resistance to achieve things that people really value can continue to be successful. BitTorrent is probably one very successful example. And BitTorrent is interesting because there's this kind of fairly prominent theory that a lot of its social value is indirect, which is it's not just about the files directly shared over the network, it's also about basically acting like a stick and prodding people like Netflix to offer better terms. Corporate censorship, not just governmental. So I go around different countries, I keep talking to government regulators, and even in various faraway lands in places like Southeast Asia, they seem friendly. They seem to want to support the technology more. But then, even despite all of these words in each of these places, blockchain projects themselves have a hugely hard time getting bank accounts. So these are projects that are not doing anything illegal. They're not doing anything that even large portions of society consider to be unethical, and banks are still shutting them out, right? So, and also finally, privacy is important too, right? So this includes things like Zcash, and includes kind of related projects in other similar spheres. So this is still a kind of side of the space that I think definitely should not be discounted. But aside from that, right, there's clearly use cases for blockchains that go beyond censorship resistance. So take CryptoKitties. Who here, if they were a government regulator in North Korea and had the values of North Koreans, would really care that much about censoring CryptoKitties? Maybe, but there's plenty of more liquid things that you could use for money laundering, right? So realistically, these are assets where you get one, and then the value might go up by a factor of 2, might go down by a factor of 4. Just steal a couple of paintings out of the art gallery, you'll be fine. So the demand for censoring CryptoKitties is low. So what's the point of putting things like CryptoKitties onto the blockchain? And I want to kind of zero in on this as a kind of a specific case study of a more general points that I like to make. So back in 2015, I wrote this blog post where I basically argued against the concept of killer dApps. And I basically said that the applications that have the highest value per user, so basically the things that people really need, are probably already here. But the thing that's not here is this entire kind of much larger area of future usage, which realistically delivers less value per person, but delivers value to a much larger set of people. And if he wants to kind of speculate about what some of those applications are, well, speculation on future usage, gray markets, black markets, then you go down, you get international payments, institutional payments, consumer payments, games, non-financial dApps, institutional stuff, and then the list goes on, and probably the bottom of the curve, there's a lot of institutional things in there as well, because those are realistically the applications that can reach more than 1 billion people the fastest. But like in any case, like basically the question we have to ask is, what is the value that blockchains are offering for the long tail? So you can, an interesting kind of part of the value of a blockchain, and what I think makes CryptoKitties psychologically attractive, as opposed to just like records in somebody's server, is the concept of permanence, right? So it's important to remember that blockchains did not invent digital assets and kind of digital, even kind of purely virtually issued digital money. Before I was in the crypto space, I played World of Warcraft for a while, and inside of World of Warcraft there was a currency called World of Warcraft Gold. World of Warcraft Gold had 0 transaction costs, could be sent to someone anywhere in the world pretty much instantly, had T=0 instant settlement, so basically like seems to be pretty much everything that we're going after. So it's clearly, there clearly isn't something sort of technically inherent in decentralization that makes those things possible. But why is it better to have a CryptoKitty as a record on the blockchain as opposed to a CryptoKitty as just a thing stored in a ledger run by some guy somewhere in California? So there's a kind of very real sense in which if you have a CryptoKitty, it's yours, right? Your ability to look at it, to trade it, to give it to someone else is all not dependent on a central issuer. The CryptoKitty's continued existence is not dependent on a central issuer. The central issuer cannot dilute them in a way that contradicts the rules of the system. Now, in reality, of course, you can, there's a bunch of caveats, like for example, CryptoKitties are really easy to dilute, you can just keep on breeding them, but that's part of the rules of the system, and by the way, in practice, the application depends heavily on centralized components, but this is still a kind of version 1 proof of concept, right? And so if you start going from version 1 to version 2, then you start thinking, you can start to see how things like digital tokens on a blockchain can actually kind of do a better job of replicating the kind of the feeling of ownership that you would get from something like physical baseball cards than anything managed on a centralized server ever can. So this, I would claim that even this kind of fairly small thing is one example of an area where blockchains like genuinely do have a competitive advantage over centralized systems, because centralized systems are just fundamentally not capable of making commitments to maintain these kinds of properties basically forever. Interoperability. So this is another, I would claim, really nice benefit of blockchains in practice. Right? So if today you decide, I am going to make an ERC20. I have this wonderful new idea that no one has ever had before. And I take this ERC20 and I issue it. So this ERC20 will immediately be usable inside of wallets. So it'll be usable inside of Status, it'll be usable inside of MetaMask, it'll be usable inside Ledger hardware wallets, it'll be usable inside MyCrypto, it'll be usable inside MyCrypto Classic, aka MyEther It'll be like basically every single kind of wallet in the ecosystem that supports ERC20s will support your thing. It will immediately be tradable on decentralized exchanges. So you will immediately be able to, for example, just start trading it on something like Uniswap. It will immediately be, balances will be trackable on Etherscan. You will be able to immediately store your ERC20 inside a multisig. You'll be able to store it inside some kind of more fancy smart contract. And in the future, you'll have more smart contract use cases that can be currency agnostic, and you can have privacy solutions that are currency agnostic. Right? So a couple of days ago, there was that announcement of Aztec, which is this privacy solution that basically encrypts the values of transactions, and they combined it together with the DAI. But really, just by changing one line of code, you could just take it and make it compatible with OMG, KNC, KYC, is that whatever. So this is, basically, this is a very real benefit of just issuing a token as an ERC20 on the Ethereum blockchain, as opposed to trying to maintain it in an Excel spreadsheet. Now, technically, of course, you could totally kind of create an ecosystem which is identical to Ethereum and which has all these interoperability benefits where the entire server is just run by Bob, right? But I would claim that there aren't really technical reasons why that can't happen, but there are good kind of social reasons why that hasn't and probably will not happen that I will get into more. So I would argue that blockchains are kind of a parallel to networked applications, and paralleling what open source did to applications on your computer, right? So in the kind of 1990s, the war basically was that you had things like Word and like all these derivatives, and they basically created these kind of silos, and then people kept on trying to kind of decipher each other's file formats and all of that. But if you instead had kind of free open source software and you used free open source software applications to deal with your files, then you would basically you would not have silos. The applications would be able to just more easily interact with the same types of files, so you could have open standards much more easily and all these other nice things. And then, to a large extent, the kind of open source and along with an open standards vision had significant successes, but there was also a big failure, which is the kind of basically the problem changed, right? So now we don't have proprietary software on our own computers. We have proprietary software on other people's computers that we just connect to, and oh, by the way, these other computers hold all of your data. So basically, the idea is that what blockchains can do is they can essentially allow you to create applications which hold data on this common neutral platform that anyone can connect to, and in doing so, you can essentially gain similar kinds of benefits, except in this time, we're not just talking about data formats, we're talking about state. And I would claim that, like, first of all, because we're talking about state, you do need this concept of a ledger, you do need this sort of common thing that everyone agrees on, and this is something which is not for technical reasons, but for social reasons, just much more feasible to do on top of a decentralized base layer than on top of Bob's computer. So another way to look at blockchains is you can think of them as a kind of add-on to cryptography, right? So what does cryptography do? Cryptography lets you hide information. I have a message, and I can encrypt the message. Yay, now everyone except the recipient can't see the message anymore. With cryptography, I can use digital signatures, and I can prove that I made a message. If I make a message and that message includes a hash of another message, then I can prove I made the second message after I made the first message. So there's a lot of things that you can do with cryptography, and you can add on to this much more fancy stuff with zero-knowledge proofs. But there are kind of things that cryptography does not let you do that blockchains do let you do. So one of them is that you can prove when you made a message. So you can prove that you made a message before some period of time. And this is called proof of existence, and you've been able to just do this with, I believe, the Bitcoin or the Ethereum blockchains for something like 5 years. You can prove that you did not make a message. So you can prove that, for example, you did not authorize an operation to transfer ownership of your accounts to some other key. You can also prove that some set of messages is the entire set of messages that some set of participants in some protocol intended to make, right? So basically, blockchains kind of strictly increase the extent to which you can assure people that you're not cheating them. Now, the kinds of cheating that cryptography prevents and the kinds of cheating that blockchains prevent are different, right? So cryptography prevents you from impersonating people. It prevents you from saying that you committing to one thing and then actually revealing some other piece of data. It prevents you from claiming false statements are true in certain cases. In the case of blockchains, basically the kinds of things that it prevents you from doing is, first of all, they prevent you from, well, really from censoring people, right? So if there is some application that's supposed to give everyone a chance to participate in some way, then as someone running the application, you can prove that you executed it in such a way that you did not kind of just fail to take someone's input into account. As just one very simple example of this, think of an auction, right? You can, clearly in an auction, there's a lot of cases where you benefit from just censoring one particular person's bid because, well, someone, the second highest bidder might want to win. So blockchain, by committing data to the blockchain, you can basically more effectively convince people that you did not do that without requiring some extra central point of trust. So example use cases. One is a certificate revocation. So basically verifying that university degrees, identity attestations, documents, blah, 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 are still valid and have not been revoked. So this is one of the kind of bigger use cases of verifying that some message has not been sent. So this is verifying that something has not been revoked. Key revocation. So verifying that the actual present day process for verifying that some particular person is you actually is the process that someone is claiming it is, even if it's possible for this process to change itself over time. So for example, if you have some cryptographic key that you use to authenticate yourself, and you want to be able to just keep on changing your key, and you want old keys to no longer be valid, then you can kind of create a gadget on a blockchain that basically kind of implements this concept of this is your account, and this is how you access it, and implements the mechanism by which the account has the ability to basically change its own access procedure. So this is valid for things, or valuable for things like self-sovereign identities. This is valuable for many different kinds of attestations, like identity attestations. There's theoretically a pretty huge number of non-financial use cases for this sort of stuff. I mentioned auctions. I also, polls are another interesting area where censorship could potentially be problematic. So let's try to delve a bit deeper into some of these social reasons that that I mentioned for why I think it's easier to kind of get an ecosystem around a decentralized network than it is to get an ecosystem around a centralized network or even a consortium network. So in game theory, there is this fairly well-known concept called common knowledge. And definition of common knowledge is this really wonderful recursive one. It basically says X is common knowledge if everyone believes that X is true, everyone believes that everyone else believes that X is true, everyone believes that everyone believes that everyone believes that X is true, and so on and so forth forever, right? So basically you can just kind of use the idea that X is true as part of an argument in any position in the argument, and it's like that's a valid thing to do. Right, so being able to kind of have common knowledge on something is very valuable for coordination, right? So I would argue that because some blockchains have these kind of fairly universally shared trust assumptions, so basically blockchains are secure because number one, they're backed by cryptography and math, and number two, the parts that are not backed by cryptography and math are backed by economic incentives, and well, who here doesn't like money? Okay, wow, still fewer people than believe lizard people literally run your government. So, like, who here believes that exactly 0 people raised their hands when I asked who here does not believe that exactly 0 people raised their hands when I asked who doesn't like money? Okay, so I see almost everyone, well, a few people that weren't in the back row. So we don't quite have common knowledge, but we, I think we're pretty close to common knowledge. So basically, because blockchains rely on these trust assumptions that are relatively easy to just be shared by very large groups of people, including people in different industries, different backgrounds, different countries. This makes it easier for communities to kind of gain common knowledge, so not just all agree, but all know that everyone else also agrees that these systems are trustworthy, right? And I would argue that blockchains have a much easier time achieving this than centralized systems. So you might ask, well, what about consortium chains, right? So consortium chains definitely do have their valuable uses, and especially now that public chain scalability is still problematic and private and public chain latency and usability are still problematic, there definitely are a lot of applications that they make much more sense for. But there's, we've heard a lot of hype about consortium chains, but we've probably seen relatively little action, right? So, what gives, right? And so here is kind of my theory for what gives, right? So first of all, just getting a bunch of people together and putting together a consortium is socially expensive. You have to fly around, you have to talk to people, you have to get people in one room, you have to pour them tea, you have to pour them wine after dinner when after you're done, you have to pay for people's stupid limos, have a bunch of meetings, maybe the meetings fail, you have to, on top of all of this, there's always just the risk that people just won't be willing to join. Convincing outsiders that joining a consortium is a fair deal is also socially expensive and socially difficult. So one common pattern that I noticed in at least a couple of consortium projects that eventually just said, I give up, we're doing Plasma, is basically that they start off saying, we want to make a consortium chain. And then they very quickly discover one partner, one big company that just says, ooh, this sounds really interesting. Sure, we'll be your kind of first user of the consortium, and we'll kind of help you set the whole thing up. Then you might get a second partner, but then they start talking to a third and fourth partner. And the third and fourth partners, they have a hard time actually signing on because, well, it's difficult to convince them that you're creating a system where they actually will be treated fairly, and it's not just something that's done for the first partner's interests. And basically, they actually have a hard time scaling up beyond 1 to 2 participants and going up to 20 or 30, right? If you're the first, then you have kind of a lot of de facto power, you get a lot of public attention out of it, and it's nice, but for the 5th or the 10th member, there's actually relatively little interest in joining. Also, getting outsiders, so people who are not part of your consortium, to trust your consortium is also something that's socially expensive. So what that basically means is, well, sure, theoretically there's these institutions and people trust them, but then one guy on the internet brings up that, oh, these are the same financial institutions that are involved in some LIBOR thing, blah, 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 and so I can't trust them. And then, you have a harder time arguing against it, and the whole thing just kind of, even if you ultimately can trust them, it's still kind of more difficult to have the conversation and just gets to the point where everyone agrees to use the thing. So basically what a lot of these consortium chain projects eventually did is they said, well, we've tried doing this for 1 year, we've tried doing this for 2 years, we give up, and we're basically just going to build some public chain-based thing, and we're going to throw it up and launch it, and we'll help other people get on, and other people are definitely free to get on, and if other people want to get on, well, they can just look at the code. They can basically just verify for themselves that this is something that they do that is going to treat them in the same way as it treated the first people to join, and is just generally something fair to participate in. Now, so far, the one disclaimer I have to give is, of course, there are basically 0 Plasma projects that are seeing a large number of users, but this is kind of the pitch that I think the space is testing for at least the next couple of years. So another thing to note is that first of all, I think the need for compromises between centralization and decentralization is real, and I definitely think that even though there are concrete places where decentralization is very useful and valuable, it's also the case that centralization provides a lot of efficiency in terms of reducing transaction costs, reducing latency, optimizing the hell out of things, and so on and so forth. And so in many cases, you are probably going to want to have compromises between the 2 extremes. But aside from consortium chains, I would say there are other kinds of compromises that institutional users should find palatable. And in just as a kind of a few different examples, I mean, first of all, there's Plasma. So Plasma basically allows you to create a kind of centralized system which publishes proofs into a blockchain and does so in such a way that the actual load on the blockchain is very low, but you get this guarantee that even if the centralized system screws up, you as a user would still be able to basically get your money out by kind of appealing to the public blockchain if there is an issue. Now, if your application is non-financial, so you don't need a kind of exit game to determine who gets what assets, and all you care about is using blockchains just to prove that something is true, then you can use basically Plasma without an exit game. So what this means is that you just publish data in Merkle trees, you publish your Merkle roots to chain, and if you want to show proof to someone that some message was not published, then what you do is you basically just literally send them your entire kind of subchain, your entire set of Merkle tree data, and they'll be able to see that, oh, in this set of Merkle tree data that I received, there was nothing, there was not a message of this type that I'm looking for. And I can also check the blockchain, and on the blockchain I can tell that the Merkle trees that someone gave to me actually contain all of the Merkle roots that were published in the chain. So basically with this kind of two-step proving algorithm, where step one, you check the chain and you make sure you got the entire list of roots, and then step two, you go through the trees, check the trees correspond to the roots, and check that none of the trees have some piece of data that you're looking for, you actually can get this assurance that says that some transaction of some particular type did not happen. Now, there are ways to kind of accelerate this much further by using blockchains together with things like Starks, but this is a conversation for another time because Starks are very spooky and complicated, but also really great fun. Aside from Merkle trees, you also have channels, right? So channels are basically a kind of, you can think of it like a mini chain between two parties, where updates to the mini chain between two parties can happen instantly, and then they only need to publish the result of their interaction at the end, as they could have 1,000 interactions between the two, but then as long as they agree on what the result is, nothing actually needs to go on chain. And this is another kind of scalability technique, and it's, I would say, also a very useful one. And it was also interesting to see that the enterprise space basically independently rediscovered something very simple or very similar when they said, oh, we want to have blockchains where you have where you can make kind of sub-blockchains between two parties where only the two parties see the data and no one else needs to be bothered with the data. Well, if that's what you want, then channels are basically exactly that, right? So, and then the last compromise, and one that will become more interesting when public blockchains become more scalable, is to just be willing to dump all of your data on chain, but you encrypt it so only a few people that need to see the data can see the data. Or instead of encrypting it, you publish zero-knowledge proofs to the data on chain. So combining together more scalable blockchains and cryptography. So there are clearly kind of a lot more things that theoretically can be done with blockchains, and I would argue a lot more systems that should use blockchains, smart contracts, kind of this entire ecosystem in some way or another. Now, the really important question we need to ask here is what technical steps do we need to get here? So who here thinks that the usability problem with cryptocurrency wallets has been solved? Okay. What species is the UK government controlled by?
Sorry?
What species is the UK government controlled by? Okay. So there's clearly a lot of work to do, right? And ultimately, if in order for public blockchains to actually really be used by a much larger set of people, there are just a lot of problems that we have to solve, right? And you can kind of see this relationship in a kind of quote mathematical model, which I don't even want to call a mathematical model because it's just a stupid chart. But basically, you know, you have this graph where the y-axis is the amount of value that an application provides per user, and the x-axis is how many users. Now, if there is a very high bar to the difficulty of usage of a blockchain, the only applications of a blockchain that will exist are the applications that can get over the usability hump. And so today the usability hump is high, and because the usability hump is high, the number of users that benefit from the blockchain enough to get over the usability hump is realistically also fairly low. Now, if we can get the usability hump much lower, then we can greatly increase the amount of usage and the total benefit from the usage. That becomes feasible tomorrow. So, what exactly is the difference between the high bar and the low bar, right? Like, what kind of things do we actually need to focus on if we want to try to push the bar down more? So, now, interestingly enough, this list is like basically exactly the same as the list that I've been trying out for the last 2 to 3 years, which on the one hand might seem like there's no progress, but in reality there's been a huge amount of progress. It's just these problems are all very hard, and to some extent, some of them are never going to be solved completely. We can only just improve things. So, scalability. 15 transactions per second. So, I think as I mentioned before, I believe 12 transactions per second is about how many transactions a second Uber uses. And I believe in Southeast Asia, you know, they have this wonderful agreement between Uber and Grab, and so now you can't use Uber anymore, you have to use Grab, so Grab is a few more transactions per second. Let's say you want to use your blockchain for something other than participating in one of the 2 largest ride-sharing monopolists, if they decided to all go on-chain. Well, no more space. So clearly, blockchains are just fundamentally scalability-wise, like, it's not even a horizontal barrier, it's literally a vertical wall that just prevents usage from going any higher. And so, how do we solve this? Well, in the short term, state channels, Plasma, Merkle trees for everything, Ziki Snark rollups, threshold signatures, blah, blah, blah. Like, a lot of the same buzzwords as we've heard for the last 2 years, but there has been a huge amount of progress in the last 1.5 years, right? So maybe 1.5 years ago, state channels on Ethereum were mostly theoretical, and now there are multiple actual real live applications that are using them. A few months ago, Plasma was entirely theoretical. Now, Plasma is not quite live, but you know, there's still a lot. There are proof of concepts, right? I mean, even a couple of weeks ago, there was this one produced by this company called The Matter, and I tried using it. I deposited it as 0.01 ETH. I tried withdrawing 0.01 ETH. Then it told me that I had to pay 0.05 ETH as a security deposit, and then I had to wait for 2 weeks, and then I think I was able to. Actually, I'm not sure if I was able to finally withdraw the coins, but so still early days, but you know, there's still a lot of progress that's been made, and even more progress that is being made fairly quickly. There is a proof of concept of Plasma Prime, which is an upgrade to Plasma Cash, which is itself an upgrade to Plasma, that is being kind of quietly but very actively worked on. So it's an area which is like moving forward very quickly. Now, in the long term, of course, there is sharding, yay, and now basically how do I describe sharding? Well, if the current Ethereum is you being in this room listening to me giving a presentation, sharding is like you taking over every single room of Imperial College and listening to Justin giving the presentation using a live stream. And if you want to move between the rooms, you can just like walk from one to the other. So way more scalability, but you know, more technical challenges, and it does kind of fundamentally change how the system works. Now, user experience. So user experience comes at multiple layers, right? So there's wallets. So there are things that we can do to make wallets have better user experience just by improving wallets by themselves. Now, there are also things that we can do at layer 1. So Ethereum has had the experience where they sent a transaction on Ethereum, and they expected it to get included fairly quickly, but then for some reason it just did not get included at all for something like 5 to 10 minutes, and then maybe half an hour later it finally got included onto the chain. Okay, see, now it turns out that this problem is largely solvable with like some fairly small layer 1 tweaks. So one thing that we can do is we can obviously just reduce the block time, and we can make the block time more constant. And that's something that's coming for proof of stake. Another thing that we can do is we can make changes to the fee market. So we can make changes to the fee market that basically remove the need to have complex fee estimation policies, and that make it much easier for wallets to just automatically immediately pay the fee that they know is optimal, or that they know is going to get included into the next block, and that is the cheapest that they can possibly pay. So I have a blog post on this, so you can look up, I think, resource pricing economics, and I don't know, with my name, and there's this big long 30-page paper where pages 19 to 20 describe how it works, but like, seems very cool, and Zcash seems interested in integrating it, so it's one of those things I'm looking forward to. And like, basically, if this happens, then you won't have to worry anymore about, do I set my gas to be low, medium, or high? Did I overpay? Did I accidentally underpay? Do I have to wait much longer? So there are things that we can do to increase user experience considerably. Also, security, right? So what exactly is the point of having a reinforced steel door on your home when the window's open? Basically, not much of a point, right? Well, okay, fine, the windows so the lizard people can come in. But the point here basically is that blockchains are, in some respects, extremely secure. If the cryptography if the cryptography works, which it seems like it works, and if you can keep your private key, and you can make sure your private key doesn't get lost or stolen, then your money is like completely secure. Problem is, people have a hard time keeping track of their private keys and making sure their private keys don't get lost or stolen. So this is a security challenge, and it is what I call a user experience of security challenge, and it's something that the space needs to solve. Security of smart contracts code. So also a big problem, one that I think is slowly improving. And I feel like the number of terrible smart contract bugs has been considerably going down over time, and I think part of that is just us knowing what the common causes of bugs are. Part of that is just us being more careful in a bunch of ways. Part of that is better tools. Part of that is better high-level languages. So that both includes Viper, and it includes the improvements to Solidity that have happened over the last year. So, and then also formal verification is starting to come in. So Uniswap, this fairly recent new decentralized exchange, did a partial formal verification of kind of the main function that runs a lot of the trading in their smart contract. So there's a lot of progress happening here, right? So what's the purpose of all this? Well, if we can make blockchains much more scalable, then supply and demand, we can reduce transaction costs to the point where instead of paying for 5 cents for a transaction, we would pay 0.05 cents, and we would keep paying 0.05 cents even if the number of users increases by a factor of 100. If we can solve user experience problems, then regular people will be more able and inclined to actually use this software, and they will be able to actually use it in a way that does not lead to some large chance per year of them losing all of their money, right? So I mean, it is a big deal, right? Back when I joined the crypto space in something like 2011 and 2012, one of the kind of really hot things to complain about was negative interest rates. And euros and Swiss francs, negative interest rate 1% a year, how terrible. But then with cryptocurrency as well, there's, for the average person, more than a 1% chance that you lose all your money in any one given year, so is it really a practical improvement? Well, not yet, but we this is something that we can improve on. And finally, if we can improve on security, then even less risk that people will lose all of their money, then we can kind of push down this bar of usage and we can make blockchains actually usable to a much larger set of people, and we can actually realize these kind of more complicated and interesting benefits that the blockchain and even the public blockchain space specifically really does have. So, thank you.